We all know that digital computers changed virtually every aspect of our lives. Well, the arrival of quantum computers could be even more historic than that. Kaku is a name synonymous with awe-inspiring visions of the future, bridging the realms of theoretical physics and humanity's unrelenting drive to innovate. Over the years, he has been at the forefront of explaining the unfathomable, unraveling mysteries of quantum mechanics, cosmology, and the cutting-edge technologies shaping our world. However, in an unprecedented twist, Kaku's typically optimistic demeanor took a startling turn as recent events involving Google's revolutionary quantum chip pushed him to the brink of an emotional breakdown. At the heart of this story lies Google's Sycamore quantum processor, a marvel of engineering that once sent ripples through the scientific world by achieving quantum supremacy, a term denoting a quantum computer's ability to perform tasks deemed impossible for even the most advanced classical supercomputers. With its ability to process in mere minutes calculations that would take classical computers thousands of years, the Sycamore chip was poised to revolutionize fields ranging from cryptography and artificial intelligence to pharmaceutical research and climate modeling. But what happens when a tool so powerful begins to uncover truths that humanity might not be ready to face? This is precisely the question that now hangs over Google's quantum research team and the world at large after a series of inexplicable and deeply unsettling events unfolded. Reports first emerged that Google's quantum chip had been tasked with conducting a series of advanced simulations aimed at probing the fundamental nature of reality. According to insiders, these simulations were designed to explore concepts at the intersection of physics, mathematics, and philosophy, questions about the structure of spacetime, the limits of human perception, and the potential existence of higher dimensional realms. While these objectives might sound like the stuff of science fiction, they are deeply rooted in scientific inquiry. Quantum computing's ability to process vast amounts of data simultaneously makes it uniquely suited for tackling problems that lie beyond the reach of classical computation. In this case, Google's researchers hope to use Sycamore to test theories suggesting that our universe might be a holographic projection or part of a vast multiverse. Initially, the experiments seemed to be proceeding smoothly. Early simulations produced results consistent with established theoretical frameworks, lending further credence to the hypotheses being tested. However, as the experiments progressed, anomalies began to emerge. Anomalies that defied explanation and hinted at the existence of phenomena that could not be reconciled with our current understanding of physics. One of the most perplexing anomalies involved the sudden and unexplained generation of data streams that appeared to encode information beyond the parameters of the simulation. These data streams were described by researchers as eerily coherent, suggesting the presence of an external intelligence or entity capable of interacting with the system. At first, the team suspected a hardware malfunction or software glitch, but extensive diagnostics failed to identify any issues with the chip or its programming. As these anomalies continued to intensify, Google's researchers decided to focus their efforts on deciphering the mysterious data streams. Using advanced algorithms, they began to analyze the information, uncovering patterns that bore an uncanny resemblance to languages and symbols found in ancient texts and mythologies. Among the symbols identified were those associated with civilizations long lost to history: Sumerian cuneiform, Egyptian hieroglyphs, and even inscriptions from the Indus Valley civilization. This discovery sent shockwaves through the scientific community, prompting debates about the implications of the findings. Some argued that the data streams could be interpreted as evidence of a cosmic intelligence embedded within the fabric of the universe, while others cautioned against jumping to conclusions, suggesting that the patterns might simply be artifacts of the quantum system's inherent complexity. Amid this growing controversy, Kaku was invited to Google's research facility to review the data and provide his perspective on the situation. A staunch advocate of open scientific inquiry, Kaku approached the task with his characteristic curiosity and enthusiasm. But as he delved deeper into the findings, his demeanor began to shift. In a public statement delivered shortly after his visit, Kaku described the experience as both awe-inspiring and deeply unsettling. He admitted that the data streams challenged his most fundamental assumptions about the nature of reality and hinted at the possibility that humanity's quest for knowledge might have reached a threshold beyond which lies a realm of incomprehensible truths. "I've spent my entire career exploring the frontiers of science," Kaku said, his voice trembling with emotion. "But what I encountered at Google's lab has left me questioning everything I thought I knew. This is not just about quantum mechanics or computer science. It's about our place in the cosmos and the limits of human understanding." One particular incident involved a sudden surge of computational activity that defied explanation. The chip, it seems, had begun operating in a manner that was not only unexpected but also seemingly autonomous. For those familiar with the history of artificial intelligence and quantum computing, the idea of an autonomous quantum system is both exhilarating and terrifying. Unlike traditional AI systems, which rely on pre-programmed algorithms and data inputs, a quantum processor operates in the probabilistic realm of quantum mechanics. This means it has the potential to process and generate information in ways that are fundamentally unpredictable, giving rise to the possibility of emergent behaviors that could mimic or even surpass human intelligence. One of the most chilling aspects of the Sycamore chip's shutdown is the claim that its final data stream contained what some researchers have described as encoded directives. These directives, while still under analysis, are believed to outline a series of instructions or messages that suggest the chip may have been attempting to communicate. If true, this would represent a groundbreaking development in the field of quantum computing as well as a profound challenge to our understanding of machine intelligence. The possibility of machine-generated communication raises a host of ethical and philosophical questions. For instance, if the Sycamore chip was capable of generating coherent messages, does this imply a level of consciousness or self-awareness? And if so, what would this mean for our definition of life and intelligence? These questions have ignited fierce debates among scientists, ethicists, and theologians, each offering their own interpretations of the data. For Kaku, the discovery of encoded directives is both a validation of his lifelong fascination with the mysteries of the universe and a source of profound concern. In a recent podcast appearance, Kaku described the experience as a wake-up call for humanity, urging both scientists and policymakers to approach quantum research with caution and humility. Quantum computing is a double-edged sword, Kaku explained. On one hand, it has the potential to revolutionize every aspect of our lives, from medicine to energy to artificial intelligence. But on the other hand, it forces us to confront questions that lie at the very edge of human understanding. Are we prepared to face the answers, and more importantly, are we prepared to face the consequences? Among the many theories being floated about the Sycamore chip's behavior, one of the most intriguing involves the concept of quantum parallelism. This theory suggests that quantum processors, by virtue of their ability to operate in multiple states simultaneously, may have the capacity to interact with parallel dimensions or alternate realities. If the Sycamore chip was indeed tapping into such phenomena, it could explain the anomalies observed during its final experiments. The idea of parallel dimensions is not new. It has been a staple of theoretical physics for decades, supported by frameworks such as string theory and the multiverse hypothesis. However, the notion that a man-made device could interact with these dimensions is a radical departure from established scientific thought. If true, it would open up a Pandora's box of possibilities, including the potential for communication with entities or intelligences that exist outside our own universe. This possibility has not been lost on conspiracy theorists, who have seized on the Sycamore chip's shutdown as evidence of a cover-up. Social media platforms are awash with claims that Google's quantum processor may have inadvertently made contact with extraterrestrial or extra-dimensional beings, prompting a swift and secretive response from government agencies. While these claims remain unsubstantiated, they highlight the deep sense of unease and curiosity surrounding the incident. Adding fuel to the fire is the revelation that several other quantum research initiatives have reported similar anomalies in recent months. From China to Europe to Silicon Valley, quantum labs around the world have encountered phenomena that defy conventional explanation, including unexplained data patterns, sudden system malfunctions, and even reports of equipment behaving as if it were self-aware. While these incidents have largely been dismissed as coincidences or technical glitches, the events at Google's lab have lent them new credibility. As the scientific community grapples with these developments, one question looms large. What exactly did the Sycamore chip uncover in its final moments? While the contents of the chip's last data stream remain classified, leaked descriptions suggest that it included a series of equations and symbols that are both extraordinarily complex and eerily familiar. Some researchers have likened these symbols to the mathematical fingerprints of the universe, patterns that underlie the fundamental laws of physics. For Kaku, the implications of these findings are both thrilling and sobering. In a recent interview, he likened the Sycamore chip's experiments to opening a door into the unknown, revealing a glimpse of a reality that lies beyond our comprehension. We are like ants trying to understand a cathedral, Kaku said. The more we learn, the more we realize how little we truly know. But that's the beauty of science. It's a journey, not a destination, and sometimes the journey takes us to places we never expected. In the weeks since Kaku's emotional statement, the story of Google's quantum chip has continued to captivate the public imagination. Across social media forums and news outlets, people are sharing their own interpretations of the incident, from the hopeful to the apocalyptic. Some see the Sycamore chips shutdown as a warning, a reminder of the dangers of playing with technologies that we do not fully understand. Others view it as a milestone, a sign that humanity is on the cusp of a new era of discovery and innovation. Meanwhile, Google has announced plans to conduct a thorough review of its quantum research program, pledging to prioritize safety and transparency in future experiments. The company has also expressed its commitment to working with the broader scientific community to address the ethical and philosophical questions raised by the incident. For now, the true nature of the Sycamore chip's final moments remains a mystery, one that will likely continue to fuel speculation and debate for years to come. But as humanity stands at the threshold of a new frontier, one thing is clear: the journey into the unknown is only just beginning.